going to be in.
There's also the link for sharing your screen there. So you need to add the Wi-Fi and join that link. Then if you go up there, I'll cast your slides up. Or not your slides, your screen. Whatever your sharing mechanism of choice.
Okay, awesome. But next we have Carson Anderson with Go Interface Tips. Give it up for Carson.
Hey, I think the spookiest thing is following that talk because that was awesome. Stumped me. So I still know what I'm talking about. Maybe don't listen to what I'm going to say. So my name is Carson Anderson. I'm the on the developer experience team here at Weave. I call myself the DevXO because no one's told me I can't. I'm on that team and I kind of make sure stuff gets done. So recently we had a internal developer meetup, and I saw a lot of kind of bad practices or things I wanted people to avoid when they use Go interfaces. They're a fantastic tool. They're the reason you didn't need generics. They're the reason you probably still don't really need generics. We had a discussion during lunch, like, you can use an interface, generics, I promise you it's better. I wrong, generics, it's just, they're magic. But I see a lot of people using and misusing. So we're going to go over some quick ideas about generics. I'll go a little bit quick over the basics, but hopefully you all kind of know how they work. Interfaces describe what something can do. That's it, right? Structs and all these other types describe data that describe what things are. Interfaces are just, what are your behaviors? That's all that matters, is how you behave. So, say we've got a dog here that's got an age, and we've got a cat that's got an age, and they have some common shared behavior. Dogs and cats, completely separate creatures, but they have things that they can both do. Now, I can, of course, create a dog and a cat separately and call methods on them. But what if I wanted to have a function that could take either or? I could do something really silly with generics now and overcomplicate my code. Run this to prove that my code works. Instead, I can say, well, there's a bunch of common behaviors. Rather than take a specific dog or a cat type, let's write a function. Let's actually write an interface that says, look, anything that can speak is going to be called an animal. You don't have to say that you're an animal. You just have a behavior and you can be that thing. So now I can create a slice of whatever, and anything that implements one method and call that. And I can pass that to functions. This is, I really stress this because you do not have to declare what you implement. Duck typing is sort of uber magic, and I don't know why anybody would want anything else. Some job a while back, I'm still bitter. So like, say interfaces are duck type, you do not have to declare. So if I have a bunch of different interfaces, animal, licker, age getter, and I have functions that take those three kinds of things, my dog interface my dog struct does not have to declare that it's three kinds of things. It just is because it is. It can do the things, so it is those things. So I can pass it without any sort of declaration. This is super magic. And I bring this up really for the next thing. There's a thing that a lot of us do in Go where we want compiler time errors a lot more whenever possible. So if I'm writing the dog struct, I'm writing the code to say I'm implementing dog, and I intend dog to always be an animal. Even if I'm not using it like an animal right now, I want the compiler to warn me, like, hey, I want to, and if I don't implement something the animal needs, tell me at compile time. And so if I run this right now, it works, but let's kind of move on, and I'll show you a little bit of magic that I see all over the place that people mistake this. So this little bit of magic snippet up here is, again, a zero memory assignment that says, look, at compile time, try to coerce a nil pointer of dog into an animal. And people see this, come from other languages and think, I have to do this or dog isn't an animal, right? Like, no. So this is really great. It's absolutely not necessary, and it's only really useful in some very specific circumstances where you're writing something with the intention of implementing somebody else's interface, and you just want to have compile time warnings in case you don't. So if I do that now, it tells me, hey, dog's missing one of these behaviors that it has to have in order to be considered an animal. You can embed interfaces, so going briefly through. I know this is a lot of basics, but I know there's new people here. So rather than making lots of big interfaces, we'll come back to that, we can describe a age getter, which has one method, and I can describe an animal, simply embed all of the behaviors of age getter into the behaviors of an animal, and an animal can now it can speak and it can get age. You don't have to make multiple interfaces. You don't have to duplicate yourself, make tiny interfaces, and you compose them up into more complex behaviors. And the more you go, the more you realize the tinier the interface, the better. So the quick tips, errors in interface. I imagine we're going to talk a lot about this in the next upcoming panel, because this is sort of one of the things that gets people a lot, and they just underutilize errors, right? They're sending them around a lot. They're using them only in string format. And you think errors are magic because you use the errors new or you use the funct error F. Both of these things do return an error. And I bring this up because if you say, well, I've never used an interface in Go, you're lying because you use it all of the time. Every single time you receive an error, you're receiving an interface. So let's dive in. Error is, again, it's built into the language. It's a very one method interface. Have a method called error, return a string. Congratulations, you're now an error type in Go. In fact, that's all that really happens with any of the other packages. So we can make our own custom errors. I won't go too much into this. There's some really great examples online of essentially saying like anything that implements error can be returned back as an error. So use that data. Errors are not just like something that you should throw up and not use. You should actually make your own types, implement the interface, and then you can absolutely see I'm making an error here, and I'm assigning my custom struct. Struct can be an error. A function can be an error. Anything can be an error in Go. And you can, I'll show you later, actually go in and dig that data back out. So you're not just passing around these kind of opaque things, but you're using that data. So a more complex example is a file info error. So here's something where I say, pass me some information about a file. And then when someone prints my error, I'm going to use that information to build you a rich error message automatically. We'll use this in a second here. So I'm going to load some file information using OS stat. I'm going to make a new file info error and print it. And you can see I'm even doing some typecasting in here to say, okay, I can print it and just deal with it as an error, but I can also force that back into one of its original types and get data back out of it. So with one instruction, I get these very like rich errors that I can, if you don't care about the details, you can just pass them up and these become rich errors for your users. But if you really want to, you can dig in. This is where you keep error codes. This is where you keep like file line numbers, all of that kind of stuff. Keep your interfaces small. I've said this before, I'll say it again. A really big client sounds great because it can do all the things, but it becomes really, really hard to mock out. The bigger your interface, the harder it is, the less to implement, the less useful that abstraction is. The smaller the abstraction, the more use it has. That's why error is so dang small. So like, well, I could do this. If I wanted to pass something to the greet function, I have to implement a bunch of things, or I have to do a big no-no and Go, which is make a struct that embeds an interface. Pretend it implements a bunch of things that just panic when you try. I'm not going to go into that because you shouldn't do it unless your specific circumstances, usually unit tests. So what do I do instead of a big interface? Make a bunch of tiny ones. I use composition, right? I have a greeter that has one method. I have a lever that has one method. I have a greeter lever that combines those two together. I have a client that then does all of the things. So I still end up with this big client, but the functions that don't need everything from the client can use the tiny interfaces. And now I have way more flexible, reusable code for this. Again, I still get that big client, but this kind of composition just makes all your code better. Don't return interfaces. I see this a lot as well. When people don't realize duck typing exists in Go, they want to make functions that return interfaces rather than just the things that they are, right? So I've got my greeter lever. I've got a happy greeter that implements three things, right? Say hello, say goodbye, and tell time. So he technically implements all three of these interfaces. He just has some extra stuff. So if I were to make a constructor function that says, okay, give me a new happy greeter, and I precast it down. I say, here's a happy greeter, but I'm going to just give it back to you as this interface type. You're hiding a behavior that is there for exactly no value, right? That I always return a happy greeter. There's no reason to cast it into something smaller ahead of time, pre-scoping down the utility of this thing I'm returning. Because now I can't call tell time on, right? Because it's not the code thinks it's a just that interface. It's not its struct. So that doesn't work. So what do I do instead? Right, this is a really tiny change. Just stop returning interfaces. 99% of the time you don't need it. There is one exception I'll point out. In very rare circumstances, you want to have a constructor or something else that returns a choice of implementations of an interface, right? So I've got two kinds of greeters here that do different things. And maybe I want my function to take the relationship I have with a person. And based on the relationship, it's going to return one of two kinds of implementation. Then, of course, that's a great use for interface because I'm saying I'm going to choose what one of these two things is. It's not always the same thing. So I'm going to abstract that and return an interface. I've never done this in production. I'm just pointing out this is the only reason I think you should ever do this. But it works and it is a good reason. Just probably will never need it. That's it. I won't keep it for now. my GitHub is applied. So
Any questions for Carson?
anybody? Yes.
So with the small interface, do you ever find yourself doing that for third-party clients as well, where I need testability in this, so I'm taking their 90 method interface and rewriting my own interface that makes it
100% of the time. No, huge. So we do a lot of stuff. GitHub generates a great Go SDK where it has like a repositories service that has 60 things on it. We have a function that needs to do one of 60. And half the time you have a function that takes an interface, and right above it, we declare a private interface with the one thing we do from that third-party client. That's a fantastic use for interfaces. And that's why duck typing is so great. Is I can have somebody else's code that doesn't know about mine fit into an interface I define. So yes, that's like one of my favorite uses of tiny interfaces, literally right above the function for third parties. Yeah.
Are there any pitfalls with doing that we should be aware of?
Not really. No, I mean, you have to keep this interface up with changes to the upstream, but that just, especially third parties, like that doesn't happen that often. You'd have to change your code anyway if that were to change. So I haven't really found any reason. Again, don't do that part. So I don't have a slide in here. Don't return interfaces, and do not make one until you're using it as an interface, right? Like, so it's great to say, here's a third party thing. It can do 60 things. I do one, so I wrote an interface for that one thing. If you're not using that interface in a unit test, don't bother, right? Just take structs until you need the abstraction. That's my only, all this cool stuff with interfaces is wait until you use them as an interface to even write them as an interface. So, good question. Yeah.
So I know saying anything good about Java is basically heresy, but I do enjoy that even though you have to pass interfaces around, you can write a lambda if it's a single method interface. And Go doesn't have that. I know there's talked about it, but I'm curious, like the, let's see, I think the HTTP handler handler has like that sort of pattern where it's an interface with one method, but then there's a type that's just the function, so that it's easier to pass in functions. Have you found yourself using that ever, so that it's easier to compose these small ones? Like, do you create a type along with the interface so that it's easier to pass in functions for these small interfaces, or has that not been so useful for you?
It's you're right. It is, and there's very specific cases like that where it's really nice, and HTTP handle function is what you're referring to, right? Where like HTTP server takes a handler that has to implement one thing. And sometimes it's nice to just pass a function and it casts it into a little wrapper. That's almost the only time I use that. I think it's sometimes really big data processing where you're making Lambda-like things, but generally speaking, it just doesn't come up a ton. So, cool. Well, thanks everybody.